Okay, so we're going to go ahead and get started. Welcome back. Today is the third and final day of this Planning Your Research series on the research process from question to analysis. And again, my name is Heather, so I'll be working with you guys today. And we are going to be talking about data specifically and analyses. So we'll be doing a little bit in Qualtrics and a little bit in SPSS, hopefully spending most of our time in SPSS. So again, this is meant to be a skills-based series, so I don't expect anyone to leave out of here with a really firm grasp on any of this stuff, but just the ability to get into SPSS or into Qualtrics and play around with it and do some basic preliminary stuff. So I still strongly encourage to reach out to your resident statistician to have them help you with the more advanced stuff, but a lot of the stuff we'll do today is really introductory. So this is meant to be really informal. If you need to leave early or go to the restroom or get more food, please feel free to do so. That will not affect me. Okay, so the basic learning objectives for today, basic understanding of Qualtrics and SPSS, as well as basic level understanding of how to interpret some data. And I will say that we'll be working primarily with the example data collection sheet that I sent, or that Shelley sent rather, earlier this week. So if you go ahead and pull that up, you'll need that for transferring to SPSS and then doing some analyses. And then this morning you should have received a PDF of the life satisfaction items. So go ahead and pull that up because we'll be working with that document as well. Okay, so we've been talking a lot about the scientific method and how to use this as the research process and guiding you in the steps. So the first three bubbles we went over in day one. So how to make an observation in your field or due to your experience or your interests, and then how to think about that observation in terms of a scientific question, looking at the literature, seeing what has been done prior to your study, and then formulating a strong research question or hypothesis. And then yesterday we talked about the data and identifying the components in your research question, what your variables are, the level of measurement you have with your variables, as well as what analyses you need. And then today we'll be taking that data and analyzing it and then interpreting it and discussing and all that. Okay, so introduction to Qualtrics. Has everyone used Qualtrics in the room? No? Okay. So we're going to see, hopefully everyone can log into it. So if you, actually I'm not going to do it that way. If you go to whatever web browser of choice you want, and then you'll go to the OU Tulsa webpage. So once you're on this page, you will click on Faculty and Staff. Qualtrics is free to use if you're a faculty, student, or staff. We have a license, the university does, and it is a survey creation, distribution, and analysis software. So it makes online surveys pretty fun to make, actually, and really easy. So once you're on the faculty and staff page, you'll click on Qualtrics Survey Software. And then it should take you to a page with a list of the different colleges with the university. And then pick your college that that applies to you. So I'm School of Community Medicine. And I believe you use your login. We'll just walk through it. We won't spend a ton of time on this, but okay. So to build a survey in Qualtrics is actually quite easy. So this is your home page whenever you pull up into the page. I have many surveys on here, but what you'll do is you'll create a project. And we're going to call this just the life satisfaction. So we'll create a new project. So really what I wanted to highlight here is how pretty user-friendly this site is. So I'm going to be working off the satisfaction with life scale and entering in some of the items. And I won't do all of them, just a couple so that you can see how to manipulate the questions in order to get the survey to look how you want it to. So you really just hover over the click to write a question. And in most ways, my life is close to ideal. Okay. And then you answer in you put in your response format. Typically this satisfaction with life scale is done on a 7-point Likert scale, but I was just doing this quickly the other day, so I just did 4 points, so we'll stick with that. But I did put the citation at the bottom of this PDF, so if you are interested in this survey and what it measures, this was created by Ed Diner, so you can find more information about it. It's a really great instrument. It's been used for a really long time, highly regarded in the field of positive psychology. So we'll start with strongly disagree. What's pretty fun about this, I think, is that it auto-populates the responses for you. So it saves you so much time. And you can choose what kind of responses you want. So do you want satisfied to dissatisfied or inappropriate to appropriate? I mean, it really takes the guesswork out of this for you. It's just entering in the questions. You know, unlikely to likely, unhappy to happy, whatever. You certainly stick with the response format that's used with the validated measure, but this is just an example of how it'll change it for you. So if we want to do disagree to agree, you can also, I like to do them horizontally to save space so I can fit more items on there, but that's just a personal preference. You can allow them to do a multiple answer. You can also force responses, and then you can do a variety. It doesn't have to be multiple choice. You can do a matrix, table, or just text entry, really rank order things, slider, all kinds of stuff. Yeah, so we did talk about that a little bit yesterday, and the way I approach that is that I think about putting your response format in a positive direction. So when you are answering the question, strongly agree is likely it's the more positive response. So you want the higher number associated with, because when you're doing a total scale score, when you total up all the items, like if you had a hope score, the higher your hope score, the more hopeful you are. So if you put strongly agree as your 1, you've actually inverted the Likert format, and then you have to go in and recode the data. And it can get really confusing at that point. So I always just make a practice of the more negatively worded item being the lower number, and then it going up. And yeah, we did talk about that yesterday. But great question. So you can create new questions. Like I said, since you guys can't do this, I want to sit here and do the whole thing for you, but I think you get the general idea of how to do this. You can edit the way the survey options are also by protecting the survey in certain ways. So do it by invitation only, or anyone can take the survey, password protect. That helps to maintain the integrity of the survey when it's going out to a lot of people. And then you can make it look nice. When you have all the questions entered in and you have it in exactly the order you want it to be in, you can change the fonts and the colors and do a lot of stuff to make it a little more aesthetically pleasing to the person taking the survey. Okay, so when you go, yeah.
One thing I wanted to highlight, because I do this a lot, when I send out surveys, I typically have, I want anonymous responses back. So if I have to send it out multiple times, I have to remember to be sure to make sure that people can only take the survey once.
Yes, great point.
That is a possibility for people who do anonymous surveys.
Yeah, and you can set that up in the distribution section here is where you can determine how you want to send the survey. Do you want to use your own email system, so your OU email, and send a reusable link or a trackable link for each person, or Qualtrics will create an email for you. So you have some options here. And then the other really great thing about Qualtrics, and I think this is likely true with SurveyMonkey, or there's another one, Zip Survey, I think. They export into SPSS and Excel really nicely, so then you don't have to do that yourself either. So if you have a completed survey and you have all your responses back, you can export it to SPSS really easily. So that's really nice. So you go to Data and Analysis, and then Export, and then you do this download your data table. And I always do SPSS. And then download, and it and then you have it in SPSS, and it's ready to go for you to analyze. Sometimes you have to do a little bit of data management as far as within the database and kind of clean it up, because sometimes the responses, the questions might come in a little weird, or there might be some extra things you don't need. Like I think it gives you the IP address of the computer, which you don't need that, so you can delete that column if you want to. I was hoping this could open so we could look at it. Yeah. Yeah, that's a really good question. I want to say yes, they do, because if you go to, I think it's in, let's see.
Do create project. Go up to the green button where it says create project, and then it says.
Right, from the library, that's right. Okay. Yeah, so I think you can look through some of these. I haven't really played around with this, so, but yeah, I think that would save even more time. Okay, well, I guess it's not going to open SPSS, so we'll move on. Oh, there it is. So do people like Qualtrics pretty well, those of you who have used it? It's pretty user-friendly.
If you do a lot of surveys, when you first set your account up, you can only create 20 surveys at a time. If you need more than that, you have to go to the local administrator, and it used to be Dr. Fox, so I'm not sure who it is right now. But they can then give you permission to have more surveys in your list of surveys at a time. Otherwise, if you have 20 and you're trying to make your 21st, you'll get a message that says you can't do that.
Oh, okay.
So just know that if you're starting out and you're getting close to 20 surveys that you have, you either need to get permission to have more, or you can save and export them out into Word, or like your database into SPSS, things like that. And then you can delete them off of Qualtrics.
Yeah, that's really good.
But I don't delete them off of Qualtrics unless I know I really don't ever want to go back to them again.
Yeah, because then you can copy those items.
I'm not sure how they're going to really re-import back.
Yeah. So like I said, this just comes in with some data that you really don't necessarily need. So you might have to do a little bit of cleaning at first, but for the most part, it's really all there for you, ready to go. So, a little intro into Qualtrics. No. Oh, yes. Okay, that dog is obviously using Qualtrics. Look at that dog. He's so awesome. I have a picture of my dog. I put her bowl of food on the table and she's eating out of it, and then I thought that might be kind of weird. So, but pretty cute when animals sit at the table or a desk. Okay. So, does anyone know what this picture is of?
Mountains.
Mountains. So perceptive. It's the Smoky Mountains, and I put it on there because I'm going there in a few weeks, so it's helping me get through creating my presentation, was that I know that I'll be there in just a few weeks, so I'll let you guys know how it is. Okay, so we're going to define a few terms, and then we will get into SPSS. So descriptive statistics and inferential statistics, both really important things to know. So descriptive statistics are just as they sound, they describe the data. I think a lot of times the importance of descriptive statistics are overlooked, but it's really key to know what your data looks like. So to know the mean, median, and mode of your data, to know the shape of your data, the range of your scores, the variance, all that kind of stuff. So I really caution people before you even get to looking for, the p-value in your statistics. Spend some time getting to know what your data actually looks like, because it will help you when it comes time to think critically about why the results are the way they are. A lot of that will tag back to what your distribution was of your data, how many people you had in the survey, what kind of people you surveyed, that kind of thing, or what what kind of charts you had, as far as if you're doing like a chart review and you're looking in the EMR at different data. So that descriptive statistics, really, really important. So can't stress that enough. We'll go over how to do that in SPSS. And then inferential statistics are also how they sound. But that basically is how your sample, if you can infer beyond your sample to the general population. So a larger or maybe a more descriptive definition of that is determining how likely it is that the results obtained from your sample are the same results that would have been obtained from the entire population. So it's like I said, the ability to infer about the larger population based on the results of your data from your sample. So we'll get into those also. Okay, a couple more terms. So power, we talked a little bit about yesterday, is the ability of a significance test to identify a true research finding. So does our study have enough power? Did we collect enough in our sample size so that when we find something that is significant, it is a true research finding? And then statistical significance is, I think, what a lot of people think of when they hear statistics. They think of that alpha level being set at the 0.05, but it refers to the probability that the results would have occurred due to chance. So you set this alpha level at the beginning, so a lot of people accept 0.05 as kind of the basic level, but you can be more stringent with that. You can be 0.01, or in medicine they'll take it to 0.001, but you set that at the beginning. And then effect size. So effect size is really, really important. It is probably the most important value that you will have from your statistics. It's the numerical expression of the magnitude of the reported relationship. And we'll get into that here. So p-value and effect size. How many people, when you think of statistics, you think of that p-value? Most people, yeah, okay. Which is right. I mean, that's what everyone talks about. Well, were the results statistically significant? The p-value was not actually meant when it was discovered, developed, and started to be used in mainstream. It was not meant to be the definitive test. The p-value was meant to indicate that there is a difference. There is something going on with this data that is not due to chance. It's the effect size that answers the so what question. So you have a statistically significant p-value. You determine there is a difference in your analysis, but so what? What does the difference mean? Is it really a meaningful difference? And effect size is overlooked so incredibly much. It's a shame because it really is a more powerful test for your data. So when you see that you have a statistically significant p-value, your next question should be, well, what was the effect size? How meaningful is this difference? Because we've all heard, well, if you get your sample size up high enough, then you could probably find something significant, right? And that's true. You can manipulate the finding a statistically significant finding if your sample size is large enough. But just because you have a significant finding, it doesn't mean that it's meaningful. So that's where the effect size comes in. So I will get off my rant about that. But this is not meant to be a full-blown statistics course. If you are interested and you want to learn more about that, I have some really great articles that are really digestible. They're not super like stats crazy language. But for those of you who are working with faculty or others on your projects, I really encourage you to have this conversation about, yes, the p-value is important, but let's look beyond that. And I'm really proud of this picture I found because to me this is, sometimes I think in pictures, and this really kind of embodies what I'm talking about. So the p-value is the tip of the iceberg, right? So it's the first thing you see. And you get excited or you get freaked out, right? You're like, oh my gosh, we have something. But the effect size is what's really going on, like what's really meaningful about the data. That's what's underneath. So I just encourage you to think about that a little bit more critically. And when you see a statistically significant p-value, be excited, but just ask that next question. What's the effect here? How meaningful is this? So I'm done with that. Signaling to move on. So for those of you who were here on Tuesday, this is the witch pumpkin. He is alive and well, as you can tell. He plays soccer. He's amazing at it. He has a mohawk and he has really killer eyelashes. So everyone thinks he's a girl, I think because of the eyelashes. I refuse to trim them. My husband gets annoyed with me because he's like, people think he's a girl. Like, I don't care, he's so cute. So that's Charles from the other day. So he's fine. He didn't die from parvo, which is really good. Okay. So for those of you who weren't here on Tuesday also, I did say I love dogs. So if you didn't catch that memo, that's where that's coming from. So I'll stop with that. Okay. I also have a cat, and I love cats too, and that is hilarious, right? It has like the milk squared and a mouse and cheese. It cracked me up the other day. Okay, so SPSS. Let's go ahead and open up SPSS on your computers. So SPSS, everyone has access to it if you're an OU student, employee, faculty, or staff. It is a statistical package for the social sciences, and it's used for data entry analysis and to create tables and graphs. So we're going to go ahead and open SPSS, and then I'm going to have you guys transfer the Excel data collection sheet like we did yesterday at the end of the hour. Transfer that over and we'll start working in that. So does everyone have this page up right now? Okay, great. You will need to, before we jump in, you'll need to make sure that that data collection sheet is saved to your desktop. It's fine. Is everyone here with their Excel data collection sheet saved somewhere? Okay, so we're going to go to File, Open, and Data. Okay, make sure that your files of type, yesterday I missed this step, says Excel. And that you're also in whatever space that it's saved in. So mine's saved on the desktop. And so I want mine's the copy of the example data collection sheet. And then we open. Okay, and then this little dialog box pops up. Basically what this is saying, you'll click OK, but what this is saying is that in the Excel sheet, the top row listed the variables, so it said subject, gender, age, that kind of thing. We want those to read as the variable names, and that is true. So we click OK. And you have your data in SPSS. So we're all good with that? Awesome. Okay, so we're going to do some quick data management, and then we'll do some analyses with this data. And if we have time, we will get to the homelessness and volunteer attitudes that we talked about yesterday. So, okay, first thing, let's go to, if you're on the data view, so down at the bottom left is the data view, and it looks very similar to Excel. If you click on the variable view, this is where you actually manipulate the data to make it change in your data view. So we're going to do a little bit of that here. So this first column, the name of the variable, corresponds to the top row here. And then all of these are in numeric format, but you can make them in many different types of formats if you want to. And string is actually letters. So if you have if you have some responses that are, someone wrote in a response, you could put that there. So width, decimals, that's just the sizing of the cells. And then label and values are the two we'll talk about. So label, this is where you actually fill in the space. So I always advocate making this first column as basic as possible, because it's the one that corresponds to this row here. And if you go in and put something like what underscore is gender, oops, if I can spell, and you go to data view and you do that for all of your questions, it just gets really muddy really quick. So I recommend making this as basic as possible. So Q1, Q2, Q3, whatever, and then labeling it with whatever the items are. And then you can use the label space to fill in your questions from the life satisfaction. So, you know, in most ways, my life is ideal, or whatever the question is. And then in this spot, in the value spot, you put in your coding from the Excel sheet. So let's do that. We'll do that, and then we'll do some descriptive statistics and some inferential statistics. So gender. We know from our Excel spreadsheet, because we looked at it yesterday, that we have the key on the second page. So we talked about how these numbers are pretty arbitrary. They're just placeholders for the qualitative differences, but we still need to know what they are because we need to know how to interpret the data. So female is 1 and male is 2. So if you know how to do this already, go for it. But if you don't, you enter in the value in. So I said female was 1 and male was 2. So female equals 1 and then male equals 2. And I just did really basic descriptions here. So now we have that. So we know we don't need values for age, because age is a continuous variable, and we talked about how important it is to treat our data at the highest level that it's meant to be treated. So we don't have categories for ages here, although we can do that in SPSS. We just have the continuous level of age. And then race, we had 1 was African American, 2 I believe was Caucasian. Oh, good Lord. Okay, and then 3 I think I did Asian. So this is this is an example of where you could use that string variable. Say you did other, you allowed someone to answer other for their race or ethnicity, and you had 4 here, and then someone did put in a 4 and they put in that they're biracial or there's something that you didn't have an option for. You can insert a variable and call it, like, we'll say race other, and you can change it to string. Oh, it doesn't like my. You can change it to string and make it however many characters you want. And then you could put in, if there was a 4 here, you could put in that narrative of information. So just helpful to provide, richness to your data and getting everything from your survey or from, if you did a chart review or something, getting everything over. Okay. Then for these life satisfactions, we need to put in what strongly agree, disagree, and strongly disagree mean. So let's go ahead and do that. So we can do 1 was, I'm just going to do SD for strongly disagree. 2 was disagree. 3, was agree. And 4 was SA. Okay, then you can make your life really easy and copy and paste. So now you don't have to redo all of those codings. Okay, I'm going to delete this stuff since we don't need it. Okay, so we will go ahead and well, never mind. Does everyone know how to, or has everyone had the opportunity to calculate like a sum score in SPSS? Some people, it looks like. We'll go ahead and do it because I think it's good practice. So when you have something like a Likert scale format with some kind of construct, and your variable is something like life satisfaction or hope or grit or secondary traumatic stress or burnout, or I could keep going on, you need your total scale score because that is what all the items are added up to, and that's the score for the person, for the respondent on that survey. So my hope score might be 25, Eden's might be 23, Kristen's might be 39, I don't know. But we all have scores that are associated with us as the respondents. So we need to do that. And while we have it in here, that's the total LS, I want to show you how to do that because it's really not hard, and it will help you to own your data a little bit more. So you have it there, and you can start doing analyses with it. So you go to transform, and we're going to go to compute variable. And so we already have total LS, but I'm going to call it LS total, I guess, for funsies. Okay, so we know that it's the 5 items. You just highlight item 1, move it over, and then we're adding it. And then you highlight item 2, move it over, add it, 3, 4, 5. And then I'm OCD, so I'm like, okay, 1, 2, 3, 4, okay, we're all there, good. And then you click OK. And then this is your output for your SPSS. It just tells you that it computed that function. So now we know that we've added all of our stuff in. You can go back to your data view and scroll over and see this LS total that we just made. So now you have total scores for all of your 10 respondents on this survey. So now let's do a couple of analyses. I did want to do a couple of other kind of like database management, but I also want to get to the analyses. So we'll go ahead and do some analyses, and then we'll, if we have time, go back to the database management. But so we've got gender, age, race, and then these life satisfaction scores. Very basic stuff, but what's something we could look at? Could we maybe do, like, what's the relationship between age and life satisfaction? With some kind of working idea that maybe as one gets older, maybe their life satisfaction goes up. I don't know. So if you got your packet and you've looked at it, I think on one of the very last pages is a decision tree for variables, and it makes it really easy. I'm going to pull it up just really quickly so you can see it. No, well, fiddles. Maybe not. There it is. Okay. Okay, well, sorry, I should have had this pulled up already. Basically, in that, on that sheet, you start at the top with your, what is your dependent variable and what level of measurement is it in, and then you can either branch off, is it a continuous level or a categorical level data. Okay, this is ridiculous. Just forget it. But basically what I was getting at was we have two continuous level variables here. So age is continuous, and then our life satisfaction total score is continuous also, right? So the first thing you can do with that is a correlation. So we'll look to see if there's a relationship here. So you go to Analyze, Correlate, Bivariate, and Pearson is already selected, so that's the Pearson's R, the one you guys have seen probably a lot. And we want age, and we want the LS total that we created. And we won't change anything else. We won't go into that, but we'll click OK. And so this is a correlation matrix. Does everyone have this pulled up on their screen? Okay. So you've got a couple things happening here. Correlation matrix is a mirrored image. So the ones that you see two ones, they serve as kind of the placeholders for the variables that are having like a relationship with themselves. But you either look on the above the ones or below the ones. So whichever one your eye is drawn to. But we're looking at this relationship between age and life satisfaction. So this first value is the Pearson correlation, the second is your p-value, and the third is your sample size. So does anyone take a stab at interpreting that? Inverse. Yep, so there's an inverse relationship, but it's not significant, right? So it's less than 0.01. But yeah, there's this negative 0.463, so actually as one is going up, the other one's going down. So as age is going up, life satisfaction is going down. Again, this is a made-up database, so I just wanted to have you guys to run that analysis. So from the output, we can actually do more. So you can just go back up to Analyze, and we can do something else. So let's look at the descriptive statistics of our data. So you'll go Analyze, Descriptive Statistics, and then Frequencies. Those look at gender and race. And then click OK. So we don't have any missing data here. We have a sample size of 10, 5 female, 5 male, so exactly 50%. And then on this race, we have 4 African American, 4 Caucasian, and 2 Asian. So there's the percent and the valid percent. So if you ever have missing data, you can look at see these are the same right now because there's no missing data. Both, everything is accounted for. But sometimes if you have missing data, someone didn't answer all the questions, which happens a lot, it will still include it under the last option. So like under male, it would say missing. It would have however many missing. And then you would look to the valid percent to give you the true percentage of male or females, because it won't include the missing data, whereas the regular percent column will include the missing data as part of your analysis. Okay, we can also do descriptives. So, analyze, descriptive statistics, and then descriptives. You can do age, and then I wonder what our mean life satisfaction score was. This options button over here will give you a lot of different fun descriptive options that you can click on. So we'll just stick with the mean, standard deviation, the min, and the max. And then OK. So our average age for this was 40 and a half, and then minimum was 22 and maximum was 61. And then for the life satisfaction, it's just right underneath. So the minimum that someone scored on life satisfaction was 11, the maximum was 18, and the average was 14. So we have gender, we have race, and we have age. Maybe there's a difference in life satisfaction based on gender. So if you were to be interested in something like that and you looked at your decision tree, you would say, okay, well, my dependent variable is the life satisfaction score because it's being acted upon by my independent variable, which is gender. Gender is doing the acting. It's the one having the influence on the dependent variable, which is the life satisfaction score. So if you're looking at your decision tree, you say, okay, my dependent variable is continuous, but my independent variable is gender, so it's categorical. So what analysis can I do? And the first one it will tell you in that decision tree is some t-test. So we'll do a t-test with gender and life satisfaction. So to do a simple t-test, you'll go to Analyze, Compare Means, and you have some options here, but we're just going to do an independent samples t-test because our grouping variable, gender, the two groups, male and female, are independent of each other. So that's the one that we're interested in. So gender is our grouping variable. We talked yesterday about using synonyms for independent variable. Well, grouping is an option. So we'll define our groups here. We know that we just used 1s and 2s, so that's easy. And then we want to move our life satisfaction total over to our test variable. And then once we're here, you click OK. So this top box is our just basic statistics. So we have our labels here for male and female, our sample size of 5 in each group, and then the average scores for the male and female on the life satisfaction scale. So on average, female scored 16.2, and on average, male scored 11.8. Then they also list your standard deviation and your standard error. This bottom box is the one that we care about for the p-value, and it's here. So yeah, there is a statistically significant difference in life satisfaction scores based on gender. And that makes sense because the female scored 16.2 and the male scored only 11.8. So there is a difference there. So what should our next question be? Yeah, what's the effect? So for a t-test, you typically compute a Cohen's d. So that you can do by hand. It's a very simple formula. It's not on here. But for ANOVAs and for regression and various other types of analyses, you can actually compute your effect size here in SPSS, and it'll say your effect size, and it'll list it there. So that would be your next question is, yeah, there's a difference. Okay, well, what is the effect? How meaningful is that difference? Okay, so we are basically out of time. We didn't get to our example research questions. I feared that we might not. I hope today you got kind of a basic understanding of how to utilize Qualtrics, how to do some database management and SPSS, and do some basic analyzing. So even if it's just descriptive statistics, that is so important to know what your data looks like. And if we would have gotten to the homelessness data, that would have come in really handy, knowing what our descriptive statistics look like. So I also hope that you maybe think about the p-value and the effect size next time you're working with faculty or on a research project. I have a great couple of articles up here. If you would like them, I'd love to send them to you. Like I said, they are not riddled with a bunch of statistical language. It's very digestible. So I hope you got something out of this. Again, I work for the Office of Research Development and Scholarly Activity. If you are on the HSC side of things, so if you're in medicine or in public health or even in some of the other HSC colleges, we're here to help. You can contact us at our website. We have a request form also. And then if you're Norman, you can still contact me. I really support all of the research going on here, and I think it's really important that we all work together, and we are all OU at the end of the day. So if you have some questions, you can shoot me an email or call me. I'd be happy to point you in the right direction or work with you on the project if my schedule allows and I could do it on my free time. So anyway, thank you guys for coming. I appreciate you spending your lunch with me for the last 3 days, and I've enjoyed being up here. I hope you've gotten something out of it. So if not, then sorry.